This is the capacitor from the rainwater harvesting pump controller. So this, even though it says 1 microfarad, isn't anymore. And I thought it would be interesting to have a go at taking it apart and see if I can see what the construction of this capacitor is, and also maybe what's gone wrong with it. I think the best way to do it would be to mill the plastic case off, so I'm going to do that and then we'll see what's inside. So I've milled the outer plastic casing of the capacitor off, and that's come off quite nicely into 2 halves. Inside we've got the potted capacitor itself, so you can see there's a plate here with one of the leads. I haven't milled the other side, and on top you can see some of the probably polystyrene there. That's actually, you can move it and it flexes slightly. What's quite interesting is underneath this case, on both sides, here and here, I don't know if you can see it on the camera, but there's what looks like some hand scraped roughing or something here, and also here. So whether that was on the mould maybe for the thing that this was cast in, or I can't believe that every capacitor is hand rough, but there's definitely some marks there which look very much like a person's come along and just done that. Not really sure why. There's also a groove there and another groove there. There's a couple of holes there. So I think what I might do next is maybe just mill that surface off here, which might give us an idea. I'll go through the polystyrene, it might make a bit of a mess, but we'll see what's in there, and maybe we can see some problems with the capacitor itself. But it's just going to be a coil of metallized polythene or something like that, some insulator. But we'll have a look at that, see if we can see the problem with it, because it's definitely not the right value. I wonder if I've changed the capacitance. It was about 288 before. Let's have a look, see if it's still a capacitor. I don't think I've damaged it very much. Oh, disconnected the battery. I've disconnected that because the battery seems to be discharging very quickly if I leave it attached, so we'll disconnect it, see if that improves the situation. 289 nanofarads, so that's roughly what it was before, so it's still a capacitor. It's still the wrong value. Okay, I'll see if I can mill off a side and see through that axis, just through here, down through there. I think that'd be better than milling the top off, because that's not going to give us much visibility, although that might be a bit more rigid, so it might be a better way of doing it. Yeah. Maybe I'll take the top off. That'll probably stop it being a capacitor, because I'll probably short out some layers or change the capacitance. Maybe we can work out what's going on. Okay. I've managed to mill away some of the potting around the capacitor, and I've also cut a slice down through the capacitor sheets themselves, so you can see that there's polythene and then metallized stuff. So you can see that this is going to be a spiral. It's interleaved metal and plastic, it looks like. Get in there, yep, so that's a plastic film. Yeah, so there's metal, there's plastic, metal, plastic. Can't see anything really wrong so far. There's always going to be a long shot. I'll just peel them off and have a look at them. So they look okay. The metal's disappeared from one end there and here, so maybe the metallization has gone a bit on some of the sheets, but yeah, you can see it's really shiny there. I don't think there's much point putting this under a microscope, because it's just sheets of metallized plastic. It'd be nice if I could unravel the whole thing. to do that I'd probably have to cut the ends off, which I could do. I might have a go at that. I might try slicing the ends off where the leads go in, these plates here, and then the whole spiral, with a bit of luck, will be easier to unravel. I might take that bit of potting off as well. So I'll try and get the bundle out and see then, when we unroll it, we may be able to see a problem in there. I doubt this is now a capacitor. It might be, because we've still got parallel plates, I suppose. Let's see what the tester thinks it is now. It thinks it's a capacitor of 287 nanofarads. So it looks to me like we've not really done much to it at all, which is a bit of a surprise. Maybe the remaining 700 nanofarads are in this bit here. Right, that worked a treat. I've taken off the plates for the contacts, and now the bottom bit of potting's just falling away, so you can see that we've now just got the spiral of foil here. So I'm going to try unwrapping that. That'll be fun. But I might put it on the microscope first, because there should be a spiral there. We'll see what we get, especially that end. I think we can probably see all the layers. So I'll do that and see what we see. So we're on the Olympus here, and you can see layers. The focus is a bit tricky because there's such a shallow depth of field on these objectives, but you can see the black lines there, which I think, well, it's either the metallization or the plastic. And as I change the focus, you can see different parts of the edge of the capacitor there. The yellow stuff, that's the remains of the potting. So if we move over, so this is the edge of the capacitor. What we got there, that must be the very edge. That must be a film. Is it the edge of the, yeah, it's probably the edge of 3 layers there, so there's quite a few layers in this thing. Let's have a look on the other side. Yeah, so you can see the wavy sort of strata of plastic. Where are we? Yeah, so we're heading off towards the edge. We were near the centre then. And it gets a bit crazier as the milling cutters rip stuff apart here. But yeah, so there's a bit more. What's there? Yeah, some other layers coming apart. There we go. So I'm going to have a go at unravelling it, see if there's anything obviously wrong, but it looks like we're not going to find out what's caused the problem. It's just too disruptive taking it apart. The manufacturers probably have a way of doing this, and they probably do it in a much more careful process. Okay, let's see what happens when we unravel it, and then I'll stick it in the bin, I think. Let's see if we can unwrap some of this. This could get messy. There we go, there's some foil. So it's looking alright at the moment. Yeah, so just lots of metal and foil. I don't see any problem there. I've cut into it there, so that's ripped. It seems to be fixed around the outside there. Yeah, so nothing obviously wrong at the moment. That's interesting. So that's tearing. Oh, that's interesting, that, because I didn't do that, and that does look. So there's strange sort of problem with the metallization there. It's not as uniform. There's holes in the metallization, so maybe that is part of the problem. It's looking, yeah, it's looking a bit dodgy there as well. Maybe the metallization has started to fail on this, because in some places like that it's just completely opaque. In other places it's got that strange mottled look, and that would sort of explain maybe what's been happening. I suspect it's been getting a bit hot. Presumably the equivalent series resistance has been dissipating, And that's the problem with using the pump too often within 1 minute. There's a limit of 25 cycles per minute. Yeah, so that looks okay there again. It could be that moisture's got in. That's the other thing, because there were actually holes in the potting. Many layers here, but it's all looking fairly good now. Don't see any problems. It's very shiny and quite densely packed now. Yeah, there's no more mottling. Let's cut that and see if we can peel those layers off. Yeah, so unlike an electrolytic capacitor, there's no fluid in here to go off or dry out, so everything looks fine. So I wouldn't have expected, oh, that's interesting, it's completely polythene there. That's sticking to me with static electricity. It's very thin film, and there's a lot of surface area. If you multiplied that up into two equivalent parallel plates, that'd be a huge surface area, and that's just for 1 microfarad. Yeah, again, so that's looking really opaque. So the metallisation on the outside of that capacitor was looking fairly iffy. So whether that was caused by heat or moisture getting in, yeah, it might have been me peeling it off because it wasn't designed to be deconstructed. Yeah, I'm getting a bit bored with this now, so I think I'm going to stop that. Oh, it's quite sparkly. So I think I'm going to put that in the bin, because I don't think I'm going to find the root cause of why that is now a 280 nanofarad capacitor instead of 1000 nanofarads. Don't know where those 300 nanofarads have gone, I can't find them. Yeah, there's many layers to go. But it did look like there was something a little bit strange with the metallisation on the outside. Maybe that was it. But anyway, I think that was my problem. I'll have to see whether the new capacitors improve the situation at all in the pump controller. It all makes sense, because if this capacitor loses capacitance, then the dropper voltage will change. With a lower capacitance, I expect the supply voltage to actually go up, I think, but I'm not sure how this was behaving in the circuit. Well, I measured it using my capacitance meter, but that's sometimes with a failing capacitor not really representative of how it's going to behave at high voltage. So it's difficult to see how this can actually fail. I mean, it's polythene with metal layers, and as long as the polythene, again, that's gone a bit mottled. Maybe it's just the way I'm pulling the metallisation off the polythene. It's difficult to see how something like that can fail. One way is that the polythene gets too hot and then the layers short together, or the whole thing just melts into a blob. Maybe that's what's happened, but it doesn't seem to have got very hot. I mean, that seems fine there. Doesn't seem to be a problem on the edges either. It's just copper where I took the plates that are making connection here away. Yeah, maybe it's not a spiral, maybe it's just layers, and one plate is this way and one's that way. I assumed it was a big spiral, but maybe it isn't. It's difficult to see how that would be attached. It's not an easy thing to make, that. I think I could make that without quite a lot of machinery. Anyway, still no real idea what's gone wrong with it, but that was what was inside. Sparkles.